Welcome to this lecture series in real analysis. In this lecture, we will discuss one-sided continuity, and it will be a very short lecture. All we need to know is what is the geometric definition of continuity at a point that we discussed, and we also saw various equivalent criterions. Okay, so let's move on. Here are two problems for practice, and now let us get started. So to define one-sided continuity, we will need the notion of one-sided epsilon band. So there are two kinds of one-sided continuity. One is right continuity and one is left continuity. In this lecture, we will only define the definition of right continuity, and we will leave the definition of left continuity to you, for you to define for yourself. At any rate, we will not be messing around too much with one-sided continuity in this lecture series. This lecture is merely for completeness. Okay, so fix an epsilon greater than 0 and a point in the plane. Then the right epsilon band about the point A, B is defined as, let me first make the diagram. So you make two lines which are at a distance of, one is epsilon distance above the point and the other is epsilon distance below the point. So here is the center line, so to say. Okay. And the band kind of starts like this. So this region is the right epsilon band. To the left of the point, nothing. We don't include anything. We include this much, this kind of open segment. This we include, meaning we do not include the end points, but we include this much. And we include everything that is between the two lines and to the right of this thing. So it will be clear when I write the formal definition. So the formal definition is just the points in R2 with the property that x is greater than equal to a and y is strictly between b minus epsilon and b plus epsilon. That's the formal definition. So this is included, this thing, and everything to the right of it. But these horizontal lines, they are not included. Okay, so I'm sure you get the definition of the right epsilon band. Similarly, you can define the left epsilon band. Okay. And now for the definition of one-sided continuity, fix a function defined on a set S of real numbers and fix a point in the domain of the function. We say that f is right continuous at the point x0 if so again, let me say the definition in words first. So whenever you choose a right epsilon band about the point in the graph corresponding to the point x0. So whenever you choose a right epsilon band about this point, there is some right delta neighborhood which we haven't defined and we will not need to define it. There is a right delta neighborhood of the point x0 such that whenever we choose a point in the right delta neighborhood, the corresponding the graph of the function restricted to this right delta neighborhood is contained in this right epsilon band. So in the geometric definition of continuity at the point x0, we just had a two-sided, the full band, and instead of the right delta neighborhood, we had the delta neighborhood. We are just replacing everything by the prefix right. So the formal definition is as follows. So if for all epsilon greater than 0, there is some delta greater than 0 such that the graph of the function restricted to this region is contained in the right epsilon band about this point. So this is the right delta neighborhood. I mean, we didn't define it, but that's what it is. And this is all the point in the domain of the function as well as in the right delta neighborhood. And the graph of the function above it should look something like this, meaning it should be contained in the right epsilon band. That is the definition of right continuity at x0. Surely you could have written this definition by yourself if you followed the definition of continuity well, and I don't want to say too much about it, but I will say this. Here are the various equivalent criteria. I haven't written the criteria via neighborhoods here, but I'm sure you can write that by yourself. So again, what we have is a function which is right continuous, we just have a function and a point x0 in the domain of the function. Then the following statements are equivalent. The first is that f is right continuous at the point x0. The second is the epsilon delta criterion corresponding to that statement. And here, in the original epsilon delta criterion, here we would see x0 minus delta less than equal to x less than equal to x0 plus delta. But that has been replaced by something which takes care only of the right side of x0. Okay, and here is the criterion via convergence. So here, when you're converging to the point x0, you're converging with this condition. So you're converging from the right. Each xn is on the right side of x0 is what this says. The rest is what it used to be. So these three things are equivalent, and you can prove them just the same way we proved the corresponding theorem for the notion of continuity at a point. There's no point repeating those proofs. And I don't want to stay too much on these things. So with that, I want to end this lecture. As usual, like, comment, share, subscribe, and I will see you next time.